Hey, Keith Van Wimmer here with VanTek Consulting. What we're going to talk about today is the TDR, or Time Domain Reflectometer. Not going to go into a lot of it about how it works and things like that. Suffice it to say that a Time Domain Reflectometer for copper works very similar to an OTDR, an Optical Time Domain Reflectometer for fiber optics. If I happen to call this an OTDR, my apologies. Just think of this as copper optics. We're going to talk specifically about doing bridge tap and how to detect a bridge tap in your network, which will absolutely kill DSL. These are what are called 1155 fault loop simulators. During training, copper training, I can sit back, or the participants can put in all kinds of various faults in this that we would basically see in our copper networks when working DSL, and then we can learn how to identify and alleviate the issues. All right. So what we have, they're 1,920 feet long. They literally are a coil of Cat5 cable sitting inside of these boxes. So 1,900 feet of physical copper in these boxes. What I've done for this situation is we have up here on the top of the boxes, we have what's called span access. This gives us the ability to put various additional faults into these boxes. Again, when we're working with copper. So what I've done is I've just taken a mid-span or span access for a bridge tap and attached that to this box. So what we have now is 1,920 feet of loop with a 1,920 foot bridge tap, and that bridge tap is located up here at 960 feet. So this meter is pretty cool. It has some various different TDR, not OTDR, but TDR functions. It has what's called a one-check TDR, which is basically, again, my fondness of auto testing anything is pretty much gone. I don't like auto testing of any sort. But there's an auto ID and a one-check TDR. This runs basically a copper test on it, gives you results. Again, just to hammer this point home, whenever you're working with or doing any kind of auto testing, make sure that you understand exactly what this meter is telling you. If the values in the meter are set up incorrectly, you're going to get a pass on this meter when in fact you're getting a fail on your copper. So again, the just caution, okay? Trust but verify. When you guys go out there and gals go out there and you're using this for testing and you're using any kind of auto test, read the numbers, learn the numbers. That will help you just immensely in your quest for copper perfection, we'll call it. So anyway, we have one check which runs an automated test, auto ID TDR. So auto ID, it goes out there and it looks at the various events that it detects on the TDR, and then it tries to put a little flag on it and says, what we think that is. So again, you get a bunch of little, we'll just do it. We get a bunch of little flags that have question marks on them. And again, that doesn't really help me in the field. For this example that we're using, it shows one event here with a short on it. I don't think I have any shorts in the system. So all the buttons are clear, everything's clear. So again, it saw something that it believes to be a short. So now you're out there at 970 feet looking for a short, when in fact at 970 feet, 960, we actually have a bridge tap. So again, when you're doing this, this can lead you down the garden path. Smart gain TDR. Smart gain, the machine adjusts the gain to what it believes is the best for that environment and for that shot. So again, the problem with this one is, and I love this function, but the problem is that it can lose some, it doesn't give you a lot of ability to adjust this and dig in and kind of see things. And then the in-home TDR, that works for, this is a different technology where this guy here, the other TDRs, the standard, the smart game, auto ID, this might be using what's called a pulse TDR. So it's sending out pulses of energy. And the in-home TDR up to about 120 feet or so, uses a technology called a step TDR, which is really good for seeing close-in events, something that's within, just at the opposite end of your leads. So it's a pretty cool thing for using in the house. So for this exercise in this video, we're going to just keep on the standard TDR. I have this set up so I can do pulse width and gain on here. So if we go out here and look, we'll just set it out. In this area, I can see, you might not be able to see it on the video, but there's a little bit of a little event there. So what we're going to do is we're going to go ahead and we're going to jump up our gain. Now I can see this starting to come out a little bit. Again, this pulse width is 8 nanoseconds, is basically 8-foot pulse, so that the frequency pulse is 8 feet long. So this attenuates just like in fiber optics. This radio frequency that's going down that copper is attenuating at roughly 3 dB per 1,000 feet. So, we have stuff peeling off of that, and it may not make it to the end. So let's go ahead and we're going to jump this pulse up, and just little tiny steps. So now we're at 29 feet. And all of a sudden what we see is we start to see little events coming in here. So we're starting to see stuff. So let's jump up our gain a little bit. Now don't get, don't go jamming this gain all the way up to here. That doesn't do us any good. So you want to just kind of get that, and I can see events, so 21 dB. I can see an event here at about 1,000 feet. At roughly 2,000 feet, I can see another event. I got one here and I got one here. This first event right here is where the bridge tap is. So we'll go ahead and put our marker on that. So about 960 feet. And it's really important when you set up your TDRs, you get what's called the velocity of propagation correct. So this velocity of propagation is how fast, that's part of the time domain, and how fast the energy is moving through the copper, 30 miles an hour. So if we know 30 miles an hour and a start time, we can calculate things out. That is the time domain. Time, a speed, from that we can extrapolate and get distances. So 960 feet. So on these boxes, I know that bridge tap that we got into is at 960 feet. So now we have 1, 2, 3 more events here. So this guy here, which is sitting out at 1950 feet. So the question is, what is that? What's sitting out there at 1950 feet? Well, that is probably, if we put a short at the end of this first box, that is the end of this box. Okay, so that's the end of our cable run. We still have up here, going through to this box, we still have another 1,920 feet on here. So that guy there, where is he? So the end of this box, if we look at that, short on this end, what we're going to get is the end of this box. So that's right there. That's about 3,000 feet. So if we move our marker over there, we've got 2969, so in that area. So what that's done is that's added 960 feet off this box, 1,920 off of here, which gives us our 2954. So 1920 plus 1,000, 2954. This last guy out here, if you think about it, we have basically 4,000 feet of cable between these two boxes. That number is the overall length of the copper in the first box and the copper in the second box, right? So we have almost 4,000 feet of copper. Even though our bridge tap is sitting up here at 960 feet, again, the total amount of copper we have comes out to 3,983 feet. That depends on your velocity of propagation. That's basic interpretation. If you want more information on TDRs, how to use them, how to test your copper, give us a holler. We run copper testing classes all the time. We come to you, bring out our labs, bring out meters, test with your meters, and basically teach you how to interpret and find faults within the copper plant. Like, subscribe, thumbs up, all that wonderful fun stuff. Give us a like on Facebook. join us on LinkedIn, link up with us, and then of course, Twitter. So hope that was helpful. Until next time, you folks be safe, and we will talk to you soon. Thanks for watching.